Okay, Algebra 1, Section 3.3. Rate of change in slope. So let's get rolling into this one. What we're going to do today, we're going to find out the slope of a line and use rate of change to solve problems. That's our objective. So let's talk about what rate of change is. It's a ratio that describes, on average, how much one quantity changes. A ratio that describes, on average, how much one quantity changes. So when we think about rate of change, we say that's the change in y over the change in x. So our y's, we know, move up and down. Our x's move left and right. And so how they change in that order. The change of y as the numerator, the change in x as the denominator. And finally, our linear functions, when we talk about linear functions, they have a constant rate of change. So the word linear here means it's going to be a line. It's going to be a straight line because it's going to be constantly moving up or constantly moving on a downward rate, or straight, sideways, or up and down. We'll talk about all those. Okay, so let's first go ahead and use this practice table here and to find the rate of change, and then try to explain its meaning. So the first thing we're going to look at is over here, number 1, number of computer games. What is the rate of change? What happens with our x's? So we go from 2 to 4, and that's a change of +2. And then we go from 4 to 6, which is also a change of +2. So that's a constant. How about the y's? The y's, if I can add this correctly, 78 to 156 is a change of 78. And from 156 to 234 is also a change of 78. So we look at our rate of change. It's a lot like those unit rate problems. Similar in that, we're looking at the change of y. Remember, it's the change in y over the change in x. So the change in y was a 78, a positive 78, and the change in x was a positive 2. So when we divide those, our constant rate of change was 39. Now, what are we talking about here? What does it mean? Well, with the number of computer games, and it was a total cost in dollars. So it was basically for every computer game, our rate of change went up $39. So that was our explaining there. On number 2 over here, we've got time driving was, again, from 2 to 4 is +2. It's not always going to be +2. It just happens to be on these examples. And then from 4 to 6, it's also +2. And then over here on the y's, from 76 to 152, we go up +76. And then from 152 to 228, check my math. Banana Man 21, are you out there? Check my math, make sure I'm right here. And we go up 76 each time. So again, I'm looking at the change in y. Remember, it's change in y over the change in x. So in this case, our change in y was 76. Our change in x, again, was 2 this time. So that gives us an answer of 38. Well, 38 what? What is the meaning here? It was the distance traveled in miles per hour. So for every 2 hours, we went 76 miles. So how much per hour did we go? We went 38 miles every hour. All right. Next, we're going to talk a little bit about slope. I'm sure you've seen some of this. Maybe you've seen this before. I don't know if you have or not. But slope, we represent with the letter M. We represent with the letter M. Get used to that. You're going to see that a lot through your math careers. This tells the steepness of a line. How steep does it rise or how steep does it fall? And rise over run, you hear that term a lot. Rise over run. And what that is, rise over run is, think about it, rise is up and down. So that's your y. And your run is left and right. When you run, you go on the ground horizontally. So y over x. Rise is up and down. Run is left and right. So it's the y and x. And think about what we talked about on that last slide was the change in y, the change in your rise over the change in x, the change in your run. So your slope is basically the change in y over the change in x. And our slope formula here is m equals, m is slope, y2 minus y1 over x2 minus x1, because you're going to have some points. I'm just going to move this up for you so you can see that a little better. You're going to have some points coordinates, and you're going to plug them in, and you can find your slope if you have points. Okay, so let's find the slope of each line here. And you can use, basically, I put a graph over here to the right, because you can use the formula, slope formula, or you can graph it. Or you can graph it. It's up to you. Sometimes they're going to tell you what they want you to do. Other times they're going to leave it up to you. So let's do both of them here. Let's do the formula first. So we've got our points here, and remember they're x comma y. So if we look at our formula, we've got m is our slope equals y2 minus y1. I'm going to put that over x2 minus x1. That's the slope formula for finding slope. So if we look at our points, it's x comma y. So we can put these as x1, y1, and then this 3, 4 point would be x2, y2. Okay? I'm just going to put that in blue so we can see that, maybe, so it's not written with the other stuff. So x1, y1, and this one over here would be x2, y2. What that basically means, this is the xy of the first point, and 3, 4, it's the xy of the second point. So now let's plug those in the formula. So I'm going to take my y2, which in this case is 4, and I'm going to subtract my y1, which is 2. And now I'm going to put the x's. So my x2 is 3, and my x1 is a -1. Now I got to be careful here because it's 3 minus a -1. So remember, we know how to change these two negatives into a positive. So be careful with your negatives here. Those are important. So now as we continue along, 4 minus 2 is going to be 2. And then 3, what ends up being plus 1 now is 2 over 4. We're never going to leave it as 2 over 4 because we know that can reduce to 1/2. So our slope would be 1/2. Now let's check out the graph, because the graph way is an easy way to do it as well. So with the graph, if we just plotted these points, -1, 2, so go backwards 1, up 2, put that there. And then if I went, say, 3, 4, it'd be 1, 2, 3, and then 1, 2, 3, 4. So here's this point. Okay? So if I made a little tiny line through those, I'm going to make it real thin. Okay? If I went through these points here, okay? That'd be my graph. Okay, one thing we can do is we can use the rise over run concept. Rise over run. How much did it rise, and then how much did it run? Okay, so when we're rising here, we can just count from one point to the other. If we're going up, how far did it go up? Well, I went up 1, 2, I went up 2, and it's going up is positive, and then I'm running horizontally, I'm going to the right 4. And we're going straight up and down and straight left and right there. So my rise, I went up 2, and my run was 4. So that's 2 over 4, which then again would equal 1/2. So either way, whatever you choose. If you have the graph available to you, maybe you just want to count rise over run. All right, number 4. This is actually going to be the practice problem. So I'm just going to write practice problem here for you, because this is what we're going to do for our notes practice problem. So we're going to skip that one and let you guys work on that for the practice problem. All right, number 5. I want to try this one out because it has a little bit of something different here. When we first put on our x1, y1, and our x2, y2. So just saying, find the slope of the line again that passes through those points. Okay, so let's do the formula first. Formula first. So m equals, again, I'm just writing the formula. It helps me remember it. You'll get to the point where you don't have to write the formula. You can just go right to the numbers. Okay, so y2 is 2, minus y1 is also 2. And then in the x's down below, it's -1 minus 1. So now, across the top here, 2 minus 2 is 0, and then -1 minus 1 is a -2. Well, 0 over anything is 0, so that's going to be, our slope would be 0 here. Okay? And so since slope deals with steepness, a slope of 0 would actually be a horizontal line. Horizontal line. Okay, and we can check that with the graph. So if we use rise over run here, let's plot these points. 1, 2 would be right here, and then negative 1, 2 would be up here. So if we drew a line through here, my plotting points would be a little bit better here, we'd have a horizontal line. And now if we talk about rise over run, our rise, did we go anywhere up and down to get from this point to the other one? No, our rise is 0. We didn't have any up and down change. And our run, sure, we went 2 notches to get from here to there, so our run was 2. Either way, that's a slope of 0. So we think about slope, horizontal slope being a 0 slope. So again, we have a slope. 0 means it's a horizontal line. It doesn't go up or down at all. It just goes straight sideways. So anytime you see a slope of 0, it's a horizontal line. Okay, moving on. Number 6, we're going to skip that one too. We can come back. We can talk about that in class. And we're actually going to skip this concept summary because I want to discuss this in class too, because there's a lot of cool things that you can look at just by looking at the graph of a line and see what it looks like just by which way it's going, how it's pointing, what the steepness is. Okay, so to review, now in this case, one more thing to go over, one more concept is to find a point if we're given the slope. So in this case, we'll use the slope formula and fill in everything you know. Fill in everything you know. And you'll have 3 of the 4 things. So we'll solve after that, and usually cross-multiplying is the easiest. Remember, you're going to have 3 of the 4 values, and then you have to cross-multiply. And then we're going to find the value of the missing coordinate. Okay? So our practice problem here. Find the value of r so that the line r6 and 10, -3 has a slope of -3 over 2. Okay, so let's start with slope formula. Again, y2 minus y1 over x2 minus x1. The only difference here is we already know what the slope is. It's the slope of -3 over 2. So that is our m. We can plug that in here. So we're going to do that. -3 over 2 is our m equals, and we've got r6 and 10, -3. So again, if I put this in, this is my x1, y1. This is my x2, y2. So when I'm plugging in these numbers, I'm going to plug in everything, but for the x1, I'm just going to have a variable of r. So y2 is -3 minus y1 of 6. And then I've got x2, 10 minus r, because that's our missing value. All right, so now it says to solve, and cross-multiplying is probably the easiest here. And especially because we got a nice little fraction here, it might be easy to cross-multiply. So when we do this, I'm just going to write them out because it makes it a little bit easier here. So let's go this way first. And -3 times 10 minus r. So in this case, again, remember this would be in parentheses. So when we do this, we're going to have to distribute. -3 times 10 would be a -30. And then -3 times a -r is a plus r. Remember, negative times a negative is a positive. And, excuse me, there'd be a plus 3r. There we go, plus 3r. So negative plus 30 plus 3r is on that side. On the other side, we've got 2 times -3 minus 6. 2 times -3 minus 6. Okay, so again, what we can do here is, if we take distributive again, we'd have 2 times -3, which is -6. And then 2 times a -6, which is a -12. Then we can combine those to be a -18. Or one faster way would probably just do, that's if we distribute, the other faster way would be just to do this in parentheses. What's -3 and -6? Well, that's going to be a -9 in here, and then -9 times 2 is going to be a -18. So either way, whatever works best for you. Probably doing the math in there first makes it a lot easier. And now we're just solving for r. So When we solve for r here, we're going to add 30 to both sides, which is going to give us 3r on the left, and on the right-hand side, we're going to have 12, because negative 18 plus 30 is 12. And so then we just divide through by 3, and then we end up with r equal to 4. Right? And so we could plug this all the way back in up here and see, does that work? We can check our work really easily to see, hey, if 4 is r, well then, does that work? Does that have the same slope as it on that line? And sure enough, it is. Okay, so back to our lesson summary, what we wanted to get to. What are 2 ways to find slope on a graph? Be specific. Actually, sorry. What are 2 ways to find slope? Gave you one of them there. Be specific. And then the practice problem we know is number 4. So sketch and find the slope of problem number 4. So sketch the graph, find the slope with the formula, and we are good to go. Okay. Bring any questions to class. Please do that, and make sure that we're in good shape here. Okay.